Students, today in this session we are going to start solid state. All of you know solid state. State of matter in which constituent particles, atoms, ions or molecules are held very close to each other and possess strong intermolecular forces. The general features of solids. Intermolecular forces are strong. Particles are very close to each other. Intermolecular forces are strong. Intermolecular space is less. Have definite shape and definite volume. Does not diffuse. Generally hard and rigid. These are the general features of solids. Students, the state of the substance, that is solid, liquid or gas, depends upon these two factors, that is intermolecular forces and thermal energy. Intermolecular forces present between the molecules. And second is thermal energy possessed by the particles due to temperature as a result of which they move. Intermolecular forces keep the particles very close to each other, whereas thermal energy, it tends to keep the particles apart at sufficiently low temperature. We know kinetic energy is directly proportional to square root of temperature according to kinetic theory of gases. At sufficiently low temperature, the thermal energy is low and intermolecular forces are strong. Now these strong intermolecular forces keep the particles very close and hence they occupy fixed positions, and this state is called solid state. That is, predominance of intermolecular forces converts gases to liquids and liquids to solids, whereas predominance of thermal energy converts solids to liquids and liquids to gases. Thermal energy possessed by the molecules due to temperature as a result of which they move. Kinetic energy due to motion, it is directly proportional to temperature. It means when they come in motion, they move apart. And intermolecular forces, more strong forces, more tightly the particles held with each other. Solids. Now the question is, students, first for your assignment, why solids are rigid? You will answer, in solids, the constituent particles are held very close to each other and hence they can oscillate about their mean path. As a result, solids are rigid. After this, next classification of solids. Students, classification of solids depending upon the arrangement of constituent particles. Constituent particles means atoms, ions or molecules. Arrangement of constituent particles. Solids are classified as crystalline solids and amorphous solids. Already mentioned arrangement of constituent particles. In crystalline solids, there is definite arrangement of constituent particles and they have regular shapes. NaCl, diamond, silver, gold, metals, etc. Amorphous solids. They have indefinite arrangement of constituent particles and possess irregular shapes. Example, glass, rubber, plastics, polymers, etc. Now, general features of crystalline solids. Crystalline solids, students, they have regular shapes. They have sharp melting points. They are true solids. They have long range order. They are anisotropic. I will clear these terms, long range order and anisotropy. They have definite enthalpy of fusion. They show cleavage property. When cut with a sharp edge tool, it split into two pieces. The newly generated pieces have plain and smooth surface. It is called cleavage property. Features of amorphous solids, students. They have irregular shapes. They don't possess sharp melting points. They are pseudo-solids or supercooled liquids, that is, possess the property of fluidity, begins to flow without undergoing any sharp change from solid to liquid. They have short range order. They are isotropic. They don't have definite enthalpy of fusion. They don't show cleavage property. If the question is distinguish crystalline and amorphous solids, you can easily mention 4 points. Regular shapes, irregular shapes. Sharp melting point, don't possess sharp melting point. They are true solids, they are pseudo solids or supercooled liquids. Long range order, short range order. Solids are classified in two types depending on the arrangement of constituent particles. Now the question for your assignment is, urea has sharp melting point while glass does not. Explain. Students, any substance, if it has sharp melting point, you know it is crystalline. Your answer is because urea is crystalline solid while glass is amorphous solid. Any substance, if it has sharp melting point, definitely it is crystalline solid. Why does window glass of the old buildings become slightly thicker at the bottom portion? Old buildings, it becomes slightly thicker. We know glass is not a true solid. It is supercooled liquid, that is pseudo solid, and possess the property of fluidity and hence makes the bottom portion slightly thicker. But students, without undergoing any sharp change from solid to liquid, it takes long duration. That's the part in question, old buildings of very ancient time. Now students, we use the term long range order in crystalline solids. That's the ionic solid crystal of NaCl. Long range order means a repeat for long time. A repeat for long time. Students, please, it's the ionic solid NaCl common salt. It is crystalline solid. When I move horizontally, what will happen, students? Na positive, Cl negative, metal, non-metal, metal, non-metal, metal, non-metal, metal, non-metal. The same pattern will repeat. It is called long range order. In crystalline solids, the arrangement of the constituent particles repeat over the entire crystal. That is, constituent particles repeat periodically. It is called long range order. Just like if I select this portion, students, if I go in this direction, the same particles, metal ions will occur. Sodium, 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 sodium. In crystalline solids, there is regular arrangement of constituent particles, which repeats itself periodically over the entire crystal. That is, constituent particles extend throughout the three-dimensional network of the crystal. It is ionic solid. With red pen, these are metal ion, and with blue pen, these are non-metal ion chloride ions. When I move horizontally, what happens? Metal, non-metal, metal, non-metals, metal, non-metal. Alternate, the same pattern repeat. And when I go in this direction, metal ions repeat. It is called long range order. In crystalline solids, there is regular arrangement of the constituent particles which repeat periodically over the entire crystal. That is, constituent particles extend throughout the three-dimensional network of the crystal. It is called long range order. Repeat for long time. In crystalline solids, the constituent particles repeat again, again and again. Next, the term we use anisotropy. Crystalline solids, they are anisotropic. Anisotropy, students, substances having different physical properties, electrical conductivity, thermal conductivity, refractive index, etc. in different directions are called anisotropic substance, and this property is called anisotropy. Now it is clear, students, when I move in this direction, the metal ions occur. Metal ions, they are good conductors. If I select this direction, non-metal ions occur. Non-metals, they are bad conductors. It is called anisotropy. Substances having different physical properties in different directions. The second term was isotropy. Substances having similar physical properties in all directions. Having similar physical properties in all directions are called isotropic substance, and this property is called isotropy. It is in amorphous solids and also in liquids and gases. Isotropy is there. I hope the concept is clear. Long range order and anisotropy. Long range, repeat for long duration. Means you will write in crystalline solids the arrangement of the constituent particles repeat over the entire crystal. This is called long range order. After this, students, the next question is, why does window glass of old buildings becomes milky in appearance? At first we study it becomes slightly thicker, then we say it is pseudo solid and possess the property of fluidity. Now the question is, it becomes milky in appearance. Students, the milkiness of glass is due to the fact that it undergoes heating during the day and cooling at night. It undergoes heating during the day. Students, you know, in the morning daytime the temperature is low, and at night during the daytime the temperature is high, and at night temperature is low. This process is called annealing, heating and cooling of a substance regularly, as a result of which it acquires some ordered structure. It is called annealing. Milkiness of the glass is due to the fact that it undergoes heating during the day and cooling at night over a number of years. Or you can directly say it is due to annealing. Annealing, it is a process that is heating of the substance during day and cooling at night regularly. So it acquires some ordered form. After this, next is classification of crystalline solid. We study in crystalline solid there is definite arrangement of particles. Now classification of crystalline solids. Students, they are classified on the basis of the nature of constituent particles. Constituent particles means atoms, ions or molecules, depending upon their nature. The crystalline solids are classified in 4 ways. The first one is ionic solids. It is clear, ionic solids, that is constituent particles are ions and are held together by strong electrostatic forces. Constituent particles are ions, the answer is within the term, and they are held together by strong electrostatic forces. NaCl, MgCl2, ZnS, metal, non-metal atom, they are ionic solids. Second, covalent solids, also called network solids. Friends, covalent bond. What is covalent bond? Mutual sharing of electrons between the combining atoms. It means in covalent solids the constituent particles are atoms. In ionic solids the constituent particles are ions. Covalent solids, constituent particles are atoms and are held together by a continuous network of covalent bonds. So we call them network solids. Just like diamond. Friends, in diamond each carbon is in link with 4 other carbons. The same pattern repeat again. Graphite, carborundum, silicon carbide is called carborundum. Boron nitride, it is also called inorganic graphite. What is the formula of inorganic graphite? Please add it in your knowledge, Bn. One you have studied in +1 class, inorganic benzene. Inorganic benzene is borazine, having the formula B3N3H6. You know benzene is C6H6. Inorganic benzene B3N3H6 because it is isoelectronic and isostructural with benzene. Covalent solids, it is clear constituent particles are atoms and are held together by a continuous network of covalent bonds. These are the examples: diamond, graphite, quartz. Quartz is solid silica. Boron nitride, carborundum. Next, student, third, metallic solids. What is your answer? The constituent particles are metal ions and free electrons and show metallic bonding. Constituent particles are metal ions and free electrons and show metallic bonding. All alloys or metals. Examples. Last one is molecular solid. It is clear, students, molecular solids, that is constituent particles are molecules and they show van der Waals forces, dipole-dipole interactions or even hydrogen bonding. Constituent particles are molecules and show dipole-dipole interactions, van der Waals forces and hydrogen bonding. The molecular solids, they are further subdivided as, we know, students, homoatomic molecule, heteroatomic molecule. It is non-polar, it is polar. Non-polar molecular solids. Second, polar molecular solid. Non-polar molecular solids, that is constituent particles are non-polar molecules or maybe even the atoms of noble gases, because they are non-bonded and show van der Waals forces. Example: solid argon, solid neon, solid hydrogen, solid CO2. It is called dry ice. Solid CO2, it is called dry ice. It is non-polar, students, because dipole moment is zero. Dipole moment of one carbon-oxygen bond cancels due to the dipole moment of another carbon-oxygen bond. Dipole moment, it is vector quantity. Vector quantity means pointing head towards more electronegative atom and tail towards less. Now in the right hand, what will happen? This direction, identical bonds, mu is equal to q into d, distance is 0, dipole moment is 0. These are non-polar molecular solids. Definition is within term. Constituent particles are non-polar molecules or maybe the atoms of noble gases. Show van der Waals forces. Constituent particles are polar molecules. They show dipole-dipole interactions. Solid HCl, solid SO2. And third are hydrogen bonded molecular solids. Again, constituent particles are polar molecules but capable of hydrogen bonding. You know hydrogen bond between hydrogen atom of one molecule and most electronegative atom, that is fluorine, oxygen or nitrogen of another molecule. The forces are called hydrogen bonding. Example: ice, solid water, solid NH3. Again, classification of crystalline solids. They are classified depending upon the nature of constituent particles. Constituent particles are ions, ionic solids. Constituent particles are atoms, covalent solids. Constituent particles are metal ions, metallic solids. Constituent particles are molecules, we call them as molecular solids. Now students, please do these questions. These are mentioned in NCERT at page number 6. Classify the following solids in different categories based upon the nature of intermolecular forces. Students, potassium sulfate, it is clear, ionic solid. Tin, it is metal, metallic solid. Benzene, urea, ammonia, water, these all are molecules. So we call them as molecular solids. Please do this question. Second question, solid A is very hard electrical insulator in solid as well as in molten state and melts at high temperature. What type of solid it is? It is insulator in solid as well as in molten state. Definitely it is covalent solid, held by a continuous network of covalent bonds. It is covalent solid, maybe diamond. Ionic solids conduct electricity in molten state but not in solid state. Students, you know in solid state, the ions are tightly held due to strong electrostatic forces, while in molten state, ions are in a position to move under the influence of electric current. Hence they conduct electricity in molten state. What type of solids are electrical in conductors, malleable and ductile? These are the properties of metal. So our answer is they are metallic solids. Please do these 4 questions. Also solve and submit me on my WhatsApp number 94595 76600. Thank you.